So myself, Nagesh, I'm working for the past 7 years in CloudControl as a DevOps engineer. Recently promoted to head of delivery. So I started my career as a AWS certified engineer. Once I did certification, then only I got job. So I started my career with AWS. I can tell that. So I got joined as a junior developer in AWS administration. After that, I got kicked into application migration, Java application migration, and then kicked into engineering, DevOps engineering, and then currently got kicked into delivery in client phase. So that's my journey. So before we start, I would like to ask few questions. You have to answer quickly and you have to raise your hand. Okay? Everybody will do that? Okay. How many of you are technical persons here? Not seeing the hands quickly. So how many of you know AWS? How many of you know Kubernetes? How many of you are feeling sleepy? I will raise my hand. I'm feeling sleepy. Okay. So before moving into it, I just want to ask some general questions. So can anybody explain evolution of transport? Currently, what we are using, human transport. How we started transporting? Started with cycle. Started with walking. Okay, and then cycle. From cycle to scooter. Scooter to car. Car to bus. Bus is not enough. Now it's train. Train is not enough. Now it's flight. Right. So when coming to that, please keep that in mind. We'll discuss about that. So my session is about today. So before starting that, our cloud control solutions is providing a product, AppG. So I'm keep working on for 7 years on that. We're providing an end-to-end automation platform tool to deploy your applications in any cloud, like on-premises, Azure, AWS, Google, within a short period of time, like 2 weeks. Whatever our applications is, we will migrate it to cloud. That's what I'm working on currently. And when coming to the today's topic, pod autoscaling and node autoscaling. So pod autoscaling is like automating the pods. Node autoscaling is like automating the nodes. That's it, right? No? Okay. And another agenda is graceful shutdown. What is it, graceful shutdown? I'm asking in simple ways, not in technical ways. Shutting down the system slowly. Okay. So this is my intro about the topic today. I'm not going to focus on PPT much. Okay, I will explain everything in detail. So before we start, I would like to give a brief intro about the containers. So if you want to do why we need pod autoscaling and why we need node autoscaling, I just want to give intro about the containers and what is Kubernetes, what is pods and all. Because I think Ashish, he is not here. I think he covered pretty much in containers. I think he gave full container course, Docker course. Okay, so containers, right? So just before we discuss that transportation, right? So we started with walking. Walking means keeping ledgers. So at that time we don't have any applications, anything. We just have to write everything in ledgers. So after that we started cycle. Started cycle means here we started with VMs, applications. One VM, one application. One VM, one database. Later that we started with bike. Nobody is going, 2, 3 is going, right? I will take 3 examples. 3 persons traveling in bike. So there it's coming in the single up VM with high spec, with better performance. They are running one application and one database within the same VM. And when coming into next level, a car, so within a single VM, they just wanted to run 4 applications. When coming into bus, so based on the demand, they just want to increase the space, right? That's so. Here the containers is like applications are equal to cycle. Running an application in a VM, containers are like running an applications in a bus. Sorry, running a containers in a car. So for a server, you can run 4 or 5 containers, 6 containers based on application size and your application resource utilization and all. So you can run that. So if you want to increase it, we can't increase the car size. We can't increase the bus size. No, we can increase train size. We can add one more bogie and increase it. Okay, that's for containers is. So we can run multiple applications in a single VM, and based on the applications, we can, even though that is not enough, well, even though we are having containers, that is not enough. And if you need any more applications based on the demand, you just need to create one more VM, or you just need to create instances. You just need to install Docker, and you just need to run the applications again. So that is still it's a time consuming, right? So when coming to pods, before coming to pods, pods is a component in Kubernetes. Pods is not nothing new. Pods is same as containers, but instead of having one container or one application, inside the pod you can run multiple containers. So inside a container, if you are having two components like API and front end, you just want to connect these two applications, and you can run two containers within the same pod, and you can connect internally. You can host your application in the Kubernetes. Okay, when coming to pods, here you can scale the pods manually. If there is any high load, you are observing that high load, your applications are consuming high CPU and all, you can immediately scale the applications. So containers, you can't scale it up. Even though you scale it up, you need to have load balancing and all. Here you don't need load balancing and all. The Kubernetes will take load balancing. How the Kubernetes will take load balancing? Like Kubernetes, there is a component service. So whatever the request coming to your application, that request will come into service. Though in the back end of service is pods. So whatever the request coming into service, that service will direct your request to pods. So here service act as a load balancer. You can set it up a cluster service, node pod. How you are accessing your application is your it's in your hand, and you can use whatever the networking process you can use for you to access your applications, cluster IP, node port, load balancer, anything. But the application, once the application request comes into service, it will automatically load balance your request to pods. So whenever there is a request, you can automatically increase the number of pods that are running under that service. So that is also we can do it within a 1 or 2 minutes, but still you need to go into server and you don't know when the load is coming high. If you are sleeping in the midnight, the load is high, you don't know, right? We can't go log in on system and we can't scale the applications. Like say I have to increase the replicas to 233. You can't do it, right? So for that, what we do is we do pod auto scaling, and we'll come to that. And before that, we can see AWS EKS over. So how many of you using AWS EKS? Everyone is using. Before AWS EKS starting, how are you running your Kubernetes clusters? It started 2017 and fully utilized at 2018 last. So before that, did you use any Kubernetes clusters or something? I was using in 2017. My product is fully on Kubernetes. So at that time, I have a challenge like the same thing, node auto scaling. Whenever there is a high load, I just have to add one more node. I don't have EKS at that time. What we did in AWS is like we created a script with Lambda function, SNS and all. So based on the metrics coming to the worker nodes, we will trigger SNS notification that will trigger Lambda. That Lambda will create a new instance, install all the dependencies, and it will add the node to whatever the master thread is there already running EC2 instances, it will add that. That's how we did auto scale, node scaling, node auto scaling at that time. So once EKS is coming, everything is easy. Not only EKS, so many services are there. So that's what EKS is. Not only the node auto scaling, there are so many features about EKS. So most of you are struggling if you are working in DevOps background, upgrading a Kubernetes cluster. How are you feeling about that? Upgrading a Kubernetes cluster from one version to another version. How many of you did that? You did, right? What was your feeling? Okay. Seventeen, 17 to 18. So in EKS, you don't have to worry about that. You don't have to maintain Windows and all. You can just go and change your version, and you can do upgradation. Easy, right? Within 1 hour, you can upgrade your cluster. And How difficult is maintaining a master? Kubernetes master. I think she knows a lot. She's laughing about that. Okay. How many of you type the kubectl get nodes command? How many times you run it? To just to check your application, your nodes is working fine. Right? So in EKS, we don't have a master. You can have a master, but still without master, you can run all the EKS nodes as nodes, and you can deploy your applications. How can we connect your Kubernetes cluster? Yeah, kubectl command, we can use it. So if you run kubectl command, it has to connect to somewhere, right? API server. So we need to have one kube config in your local or any other server. You just need to keep that config, and using that config, we can connect to EKS clusters, right? So using that EKS clusters, we can deploy all the workloads. You just need to maintain the server. You don't need to maintain server. You can have that conf in your Windows machine, and you can run the commands. Right? In the command prompt, you can have the config in your local. You can install kubectl. You can run the kubectl commands in Windows machine as well, and you can deploy your workloads into the EKS. So that's the use of EKS, and the scalability, compatibility, and security wise. So whatever the services you are using in AWS, you don't have to expose it to outside. You can connect all the services internally to EKS. So when coming to pod auto scaling, right? So we just wanted to increase the number of people. Too many passengers in the bus stand, the bus size is not increasing. Okay, what we can do? So we just wanted to increase the pods in this cluster. So I can't go in every time and manually increase the size of the cluster. So what I want to do is I wanted to automate that process, increasing the pods based on the demand. Once the demand is completed, it has to go down automatically. So that's why we are using pod auto scaling. So pod auto scaling is like if you are using any enterprise applications, e-commerce applications, you can't expect when the demand will be high. You can't expect when the users are logging into your application, even when they are going to use it, when they are going to make it down. So at the time you can use pod auto scaling. So to use pod auto scaling, we need to have metrics server inside the Kubernetes, which is gathering all the metrics of your pods running in a Kubernetes cluster. All the metrics, how much CPU utilization it is doing, how much memory it is utilizing, how much disk IO space it is utilizing, what is the IO rate of that pod, everything it will gather. So once you install that metrics server in your Kubernetes cluster, either it is EKS, AKS, KubeADM, MicroK8, whatever it is, you can collect all the metrics for the pods running in a Kubernetes master or cluster. Okay, so based on that, we are going to implement the pod auto scaling. So there are three types of pod auto scaling. One is horizontal, one is vertical, one is autoscaler. Autoscaler is nothing but node auto scaling. So we can discuss about horizontal pod auto scaling. So how many of you are running your application with the resource limits? So how much CPU you are giving, how much memory you are giving for your application? It depends. So can you give me an example? One CPU, two CPU, or 1 GB, 500 MB. Okay. So we are running an application with 8 core 32 GB. Okay. So it's not enough for that application. Okay. So it's one of our client application. I don't want to reveal the name. It's not enough for that. So we're keeping that because it will utilize all the CPUs in that node. Not only in that node, if it is possible, it will utilize all the CPU in the all worker nodes. So that's why we're keeping it under resource limits. So resource limits is usually like keeping your pod in a room, making it not to go out of this room. Like within the 8 CPU, that application has to work or break. Even though there is a high CPU utilization, it has to serve under this 8 core CPU utilization. If it can't perform, if the application is not able to bear that load, it will break and it keep on restarting. That's the CPU utilization. So once you are having CPU utilization, right, whenever there is a high load you are expecting, What it will do, it will reach 8 CPU, it will completely utilize 8 CPU. So once it reaches that limit, your application will go down. It will not able to handle your load. So there is no use that you are having resource utilization on your pod. So you just wanted to distribute the load from that pod when there is a high CPU utilization. So that at that time, even though we can keep that pod reaching 8 CPU and we can distribute the load into another pod, and once the load is reduced, we can delete that pod or remove that pod automatically using pod autoscaling. So horizontal pod autoscaling like that only if you are assigning 10 CPU or 32 GB RAM for an application. So if there is a pod running for that application, if there is a high CPU, once if it scales up, it will scale up on another application within that same 10 CPU. It will use the same 10 CPU core and 32 GB RAM to upgrade your pod, making it from reducing the load on the pods. So when coming to vertical pod auto scaling, so you are setting a limit of 80% or 50% or 70%. Some applications will not give time. So once it reaches 70, it will directly hit 100. It will not hit 80, it will not hit 90, it will directly hit 100 century. So at that time, we can't expect that that application will work. So what we do is we can keep the resource limit very low, limit, I'm saying limit. So if you are keeping 10 CPU, you can say like 50% or 70%, 75% based on your application. You can keep the limit. Once that limit reached in that pod, so you can scale up on another pod with the same limit, the same resource limit with 8 core CPU, 32 GB RAM, 10 core CPU, 32 GB RAM. You can scale up on another pod and you can run the application. Once the load is reduced, that pod will get removed. Okay, you are upgrading the pod, 10 core CPU, 32 GB RAM. That server is having 20 core CPU, 64 GB RAM. What will happen to that server if both the pods are using 10 core CPU and 34 GB RAM? Sorry, 64 GB RAM. The node will go out of CPU, right? So at that case, and even though both pods are reached their limit, and it will try to create another pod. If there is any space in another worker node, it will create. If there is no space, it will not able to create. So at that time, your cluster or one of your worker node will go down, or all the worker nodes will go down. So at that time, we need node auto scaling. Node auto scaling means whenever there is a pods in pending state, because of this high CPU resource limits, high load average and all, whenever there is a pod in resource pending state in a cluster, it will automatically try to create a new node. It will check the scheduler. If there is any pending pods, that autoscaler will trigger and it will create a new node. How this will autoscale will trigger in EKS? I'm not going into depth. I will just explain in briefly. So autoscale will trigger is like, how many of you know autoscaling in EC2? Everyone knows, right? So once you created an EKS instance in AWS, you can go to EC2 autoscaling. There you can see autoscaling. When you and so you are creating a launch template for autoscaling, you can see EKS branch node pool. So you can select that node pool. You can specify the number of max and minimum nodes. And once you are done, you need to run 2 or 3 AMLs inside the cluster. Once you are executed that, your EKS is ready to do the node autoscaling. It's very simple process, and the best document for your AWS service is AWS document only. In my career, there are only 2 documents providing full information. One is AWS and second one is Kubernetes. Kubernetes, Google Kubernetes, KubeADM. They are providing very good document, and AWS is also doing very good in their documentation. Whenever there is an upgrade or change something, they will immediately updating it. So this is for pod auto scaling. So whenever there is an create a new pod. There also a limit is there. You can set minimum number and maximum number for the pods. If you have wanted to have 2 minimum replicas means 2 pods. If you wanted to have max 5, and you don't want to load your node, so you can keep that count based on your resource available in that node or in your all worker nodes. You can set the limit and you can run it. So this is, you don't have to set any limit. You can set 4 or 5 or 6. Here also there is a limit, billing. That one you have to keep in mind how many instances you are creating. So if you say 10, it will create 10 instances whenever there is a high load instances, and it will get running on for 10 or 15 minutes even there is no load errors. Okay, so before that, we're done with pod auto scaling and node auto scaling. Anyone have any questions on that? No one? Yeah. Roll back the worker nodes. So once your load is reduced, it will automatically lead that node. EKS rollback, right? So if your rollback is not successful, EKS will automatically roll back to your previous versions. If it is successful, I didn't see any rollback option in that. I haven't tried yet. If the upgradation is failed, then you can automatically roll back to older versions. So after successful upgrade, I didn't face that scenario till yet. Application failure features is regarding your Docker image only, right? We can't say it's because of the Kubernetes. It's related to your Docker image. Limit. Yeah.
Currently, we only set for memory. No limit is set for CPU. So is it mandatory or it is recommended as a best practice to set CPU limit also?
So when coming to that, some applications will use CPU, some applications will high memory. Both, if your application is utilizing both, you can set the limits for both. Both CPU and memory, you can set the limits. So based on the limits, your application will trigger. Uh, you can know these values when you have a load testing on your application. So load testing is, I think many of you know what is load testing is. So I'll explain in brief about that. So because you know that too as well, thanks for bringing that point. So you know that one because how you are setting your limits to your application. Without proper load balancing, you can't set your limits to your application. So load balancing is like loading your application based on requirements. Let's say you're having an e-commerce application. For an hour, 1,000 users are going to trigger your application or use your application. You just need to keep the load on your application minimum 5 to 10 minutes or 15 minutes. So if that 5 to 10 minutes with 1,000 users with multiple threads, your application is withstanding, at that time you will observe how much CPU, how much memory it is utilizing. Based on that, you will set the request. CPU request and memory request. You can't go blindly and set the CPU and memory request. If you are going to do that, you can set the maximum number of nodes to 100. Then you can do that. You are freely welcome on that. AWS is not restricting on that. Okay. So, any other questions? We can't set both HP and VPA. Not to have both HP and VPA on the same cluster, we can have either one HPA or VPA. VPA is the best practice currently. HPA is in still developing stage. It's not giving proper results as they are telling. VPA is providing the proper results and we are using that VPA only. You can use VPA. I suggest VPA only. Any other questions? Okay, let's move on to that graceful shutdown. So graceful shutdown, I think someone explained, right? Slowly terminating the instances. So what do you mean by slowly terminating the instances or pods? Drain the pods. So before that, when you are upgrading your applications, right? Doing pod auto scaling or node auto scaling. So we need to do one more thing there. You have to enable readiness probe on your pods. What do you mean by readiness probe? Thank you for that. Readiness probe is like once you enable the readiness probe is just a curl command that you are enabling on your application using Kubernetes. So once you enable readiness probe on your application, you can define this in the deployment YAML itself. So once you enabled it, what it will do is, even though the pod is up, it will take some time to application is up and running. It will take some startup process. It will take some time to connect to DB and all. So at that time, usually there is high load and it scaled up a pod. What service will do is it will automatically send the request to that pod, even though application is not ready. So at that time, your users face some errors or application connectivity issues. So for that, we need to enable readiness probe. So once you enable readiness probe, Kubernetes will tell the service that this particular pod scaled up is ready to receive the request. So we need to enable readiness probe and metric server and load testing on your application. Then only we can enable VPA or whatever pod auto scaling, HPA or VPA. So okay, before starting we are looking is the application is up or not. Before shutdowning also we need to look, right, anyone in the shopping mall or not. Right, we need to observe that any requests are coming to that pod or not. We can't do that manually. So what we need to do is we need to enable graceful shutdown. So we are giving some time to that pod to shut down automatically. So even the pod auto scaling is CPU utilization, memory utilization is reduced below your limits, and what it will do is it will automatically reduce the minimum number of counts. Even the node, even the pod, whatever, it will reduce the minimum number of count. When there is no requests are high load and your CPU memory utilization very low, it will automatically reduce the number of pods and nodes. So at that time, what it will do is, it will tell that auto scaling, is it auto scaling, go and terminate that node. But it doesn't know that there are some applications are running. That application has to be closed first. They are receiving some requests. So there we need to this graceful shutdown. What it will do is, so whenever there is an application, kube scheduler will trigger the request to terminate that pod. So when the kube scheduler initiate a request to terminate the pod, it will start the sig term to kill that particular pod. So even though kube scheduler trigger to kill that pod, the pod will remain in running state for 30 seconds. So within that 30 seconds, it will not receive any new requests. So it will process the old requests that are currently running into that application or that pod. It will process that request and all, everything in that 30 seconds. So once that is done, it will shut down the pod. So that is for graceful shutdown. So once you are enabling these, we need to consider all these load testing, readiness probe, metric server installation in your Kubernetes, and when you are doing downgrading the pod auto scaling, node auto scaling, you have to enable that graceful shutdown and node auto scaling also. So that's it from my side. Thank you. Thanks for your time. Anyone having any questions on that?